This is week 2 of MBA 824, Systems Analysis and Design. This week we will extensively cover project management, what it means, who does it, and how they go about it. That will be chapter 3. We'll also take a look at 2 of the tools in the Systems Analyst Toolkit. We'll talk about communications tools. These you're probably familiar with and for the most part are common sense, but they're an exceptionally good review. But also Toolkit B, which covers case tools, which if you're not in the IT world is probably a concept you're not familiar with. Chapters 1, 2, and 3 make up the planning phase of the software development lifecycle. Chapter 3 is the final chapter in the planning phase. In this chapter, you'll learn about project management, how to plan, schedule, monitor, and report on IT projects. You'll also learn how to control and manage project changes as they occur. Project management for IT professionals includes planning, scheduling, monitoring, controlling, and reporting on information systems development. A successful project has to be completed on time, within budget, and it has to deliver a quality product that satisfies the users and meets all the requirements. Project management techniques can be used throughout the software development lifecycle. System developers can initiate a formal project as early as the preliminary investigation stage or later on as analysis, design, and implementation activities occur. Whether a project involves a new office building or an information system, good leadership is essential. In a systems project, the project manager or project leader is usually the senior systems analyst or an IT department manager if the project is large. An analyst or a programmer analyst might manage smaller projects. In addition to the project manager, most large projects have what's called a project coordinator. The project coordinator handles the administrative responsibilities for the team and negotiates with users who might have conflicting requirements or want changes that would require additional time or expense. Project managers typically perform 4 activities. These include planning, scheduling, monitoring, and reporting. Planning the project includes identifying all the project tasks and estimating the completion time and costs of each. Scheduling involves the creation of a specific timetable, usually in the form of charts that show tasks, task dependencies, and critical tasks that might delay the project. Scheduling also involves selecting and staffing the project team and assigning specific tasks to team members. Project monitoring requires guiding, supervising, and coordinating the project team's workload. The project manager must coordinate the progress, evaluate the results, and take corrective actions when necessary to control the project and stay on target. Finally, project reporting includes regular progress reports to management, users, and the project team itself. Effective reporting requires strong communication skills and a sense of what others need and want to know about the project. On any given day, a project manager might perform one or more of the activities we talked about. However, each of these activities is actually part of a larger framework, which includes 3 key steps in project planning. This is to create a work breakdown structure, identify task patterns, and also to calculate the critical path. A work breakdown structure involves breaking a project down into smaller tasks. Before you create a work breakdown structure, however, you need to understand the 2 primary types of charts. These are Gantt charts and PERT CPM charts. A Gantt chart is a horizontal bar chart that represents a set of tasks. For example, the Gantt chart in figure 3-6 on page 104 in your text displays 5 tasks in a vertical array with time shown on the horizontal axis. The position of the bar shows the planned starting and ending time of each task, and the length of the bar indicates its duration. On the horizontal axis, time can be shown as elapsed time from a fixed starting point or as an actual calendar date. A Gantt chart can simplify a complex project by combining several activities into a task group. The Program Evaluation Review Technique, or PERT, was developed by the U.S. Navy to manage very large, complex projects, such as the construction of nuclear submarines. At approximately the same time, the critical path method was developed by private industry to meet similar project management needs. The distinction between the two methods has disappeared over time, and today the technique is simply called either a PERT CPM or a PERT/CPM chart. PERT is what is referred to as a bottom-up technique because it analyzes large, complex projects as a series of individual tasks. To create a PERT chart, you first identify all the project tasks and estimate how much time each task will take to perform. Next, you must determine the logical order in which the tasks must be performed. For example, some tasks can't start until others have been completed. In other situations, several tasks can be performed simultaneously or concurrently. Once you know the tasks, their durations, and the order in which they must be performed, you can calculate the time that it will take to complete the project. You also can identify the specific tasks that will be critical to a project's completion. So which type of chart is better? Well, actually they both have their place in project management. The Gantt chart offers a valuable snapshot view of the project, but PERT charts are more careful and more useful for scheduling, monitoring, and controlling the actual work. With a PERT chart, a project manager can convert a task start and finish time into an actual date by laying out the entire project on a calendar. Then on any given day, the manager can compare what should be happening with what is taking place and react accordingly. Also, PERT charts display complex task patterns and relationships. This information is valuable to a manager who is trying to address high-priority issues. PERT and Gantt charts are not mutually exclusive techniques, and project managers most often use both. A work breakdown structure must clearly identify each task and include an estimated duration. A task or activity is any work that has a beginning and an end time and requires the use of company resources such as people, time, or money. Some examples of tasks would be conducting interviews, designing a report, selecting software, waiting for the delivery of equipment, or training users. Tasks are the basic units of work that the project manager plans, schedules, and monitors, and they should be relatively small and manageable. In addition to tasks, every project has events or milestones. An event or a milestone is a recognizable reference point that you can use to monitor progress. For example, an event might be the start of user training, the conversion of a system data, or the completion of the interviews. A milestone such as complete 50% of the program testing would not be useful information unless you could determine exactly when that event will occur. The first step in creating a work breakdown structure is to list all the tasks. And while this step sounds fairly simple, it can be challenging because the tasks might be embedded in a document. In your text, go to page 106 and refer to the document on the lower left-hand side of the page. One trick is to start by highlighting the individual tasks as shown in the second version of that document in red in your text. Adding bullets makes the tasks stand out more clearly as shown in the third version of the document. The next step is to number the tasks and create a table shown on this chart, shown on this slide, similar to the one in figure 3.10 in the text, with columns for task number, description, duration, and predecessor tasks. Our next step in creating a work breakdown structure is to estimate the task durations. This can be measured in hours, days, weeks, or months, depending on the project. A person day represents the work that one person can complete in one day. This approach, however, can present some problems. For example, if it will take one person 20 days to perform a particular task, it might not be true that 2 people could complete the same task in 10 days, or that 10 people could perform the task in 2 days. Some tasks can be divided evenly, so it is possible to use different combinations of time and people, but only up to a point. Project managers often use what's called a weighted formula for establishing the duration of each task. The project manager first makes 3 time estimates for each task: an optimistic or best case, identified as B, a probable case estimate, P, and a pessimistic or worst case estimate, which is W. Now that we have our 3 estimates, the manager assigns a weight, which is an importance value, to each estimate. The weight can vary, but a common approach is to use a ratio of B equals 1, P equals 4, and W equals 1. The expected task duration is then calculated using the formula shown below: B plus 4P plus W divided by 6. In identifying the tasks, there are several factors which can affect duration. The first of these, of course, is project size and scope. Understandably, the more tasks you have, the greater the size of your project, the greater the duration. But human resources can affect duration as well. A project manager has to assemble and guide a development team that has the skill and experience to handle the project. If necessary, additional systems analysts or programmers might have to be hired and trained, and all of this has to be accomplished within a specified time frame. Obviously, my task durations would be shorter the more experienced my project team. And finally, a project manager has to define system requirements that can be achieved realistically within the required constraints. In the absence of constraints, the project manager simply calculates the resources needed. However, there are very few projects that don't have constraints. If you're managing a very complex project where you have many tasks, you can use the task groups like we talked about in the Gantt chart to simplify the list. A task group is under a larger task heading, and in Microsoft Project you can simply click on a plus sign next to that task to display all the tasks within that group. It's a very useful tool in displaying complex projects. Identifying task patterns involves going through all the tasks once you have them laid out and finding the dependencies between those tasks and essentially mapping those out. There'll be numerous kinds of tasks and task dependencies that we will talk about on the next couple slides. In this slide, we're going to talk about how we use task boxes to create a model. In a PERT CPM chart, project tasks are shown as rectangular boxes like the one shown here, and arranged in the sequence in which they have to be performed. Each task box includes, as you can see, a task name, ID, duration, start date, and finish date. Now the task name should be descriptive, but it doesn't have to be unique. So for example, conduct interviews. You might actually use that task again, that name. The next is the task ID. It can be a number or a code that does provide a unique identification. This task ID cannot be repeated. The task duration is just what you think it is. It's the amount of time it will take to complete the task. And then of course you have to have a start date and a finish date. There are 3 main types of task patterns. The first is what we call dependent tasks. The second is multiple successor tasks. And the third is multiple predecessor tasks. A dependent task would be where a task has to be completed, tasks have to be completed one after another. These then are called dependent because one depends on the other. Multiple successor tasks are when several tasks can start at the same time. Each of those is called a concurrent task. Often 2 or more concurrent tasks depend though on a single prior task, which is called a predecessor task. In this situation, each concurrent task is called a successor task. And finally, we have multiple predecessor tasks. Suppose that a task requires 2 or more prior tasks to be completed before it can be started. Since the 2 prior tasks might not finish at the same time, the longest or latest predecessor task becomes the controlling factor. As we've already indicated, task patterns determine the order in which the tasks are performed. Once the sequence has been defined, then the project manager can schedule the tasks and calculate what's called the critical path. And this is an absolutely essential concept. A critical path is a series of tasks which, if any one is delayed, would affect the completion date of the overall project. If any task on the critical path falls behind schedule, or the entire project will be delayed. Project managers must always be aware of the critical path because they need to respond very quickly to keep the project on track. MS Project and other project management software can highlight the series of tasks that form the critical path. And in the next few slides, we'll talk about exactly how that is calculated. How do you calculate the critical path? Well, first, you're going to review all your task patterns. Remember, that's the dependencies, when tasks have to start, which depend on which, those kinds of things. The next step is you have to determine the start and the finish dates, which is going to determine the critical path for the entire project. And we also have to mention something called slack time, and this is the amount of time that a task could be delayed or late without pushing back the completion date of the entire project. In the slide itself, you don't have enough information. You need to look on pages 113 and 114 in the textbook and understand how to calculate critical path. Again, this is an essential concept. You shouldn't move forward until you have a firm understanding of how the critical path is calculated. Monitoring and controlling the project are two of the project manager's primary responsibilities. This is done in a number of ways, and we'll go over a few of them. But one of the primary techniques that's used is called a structured walkthrough. It is a review of the project team's work that is done by other members of the team. Generally, though, systems analysts will review the work of other systems analysts, programmers review the work of other programmers. Structured walkthroughs take place at several points throughout the software development lifecycle. They can be called other names like code reviews, design reviews, testing reviews. It just depends on which phase of the project they occur in. Another of the project manager's primary responsibilities is maintaining the schedule, and this is an area where many projects get into trouble. Things like project creep and scope creep will get in here and wreak havoc. In maintaining a project schedule, you're going to become very familiar with the PERT chart, PERT/CPM chart, and you're going to want to keep track of that very carefully. The critical path, as we've already mentioned, is essential to you, so you're going to be watching that at all times. The better you put your project plan together at the outset, the better you'll be able to manage as time goes by. And you do that through milestones and checkpoints. You create these milestones and checkpoints as a point at which you look and say, okay, we got any problems here? We got anything that's going to need to be fixed? Is there anything that looks like it's going to be a future problem? Most project managers spend a great deal of their time tracking the tasks on the critical path. And as you get into project management, you'll find just exactly how true this is. In a project, reporting is not just a one-way street. You have both upwards, lateral, and downward reporting that has to be accomplished. There's any number of ways that you can gather the information you need to create these reports. One is project status meetings, which you're probably all familiar with already, that are just regularly scheduled meetings where the team gets together and discusses the project status, issues, any problems. This is also a great place to coordinate issues between different team members. They're time consuming, but they really are essential. You'll also create what are called project status reports. And these will be available to your project team member, and different versions of the of the project status reports will go up to management as well. Risk management is the process of identifying, analyzing, anticipating, and monitoring risks so as to minimize their impact on the project. Now, the first step in risk management is to develop a very specific plan. Although project management experts differ with regard to the number of steps or phases, a basic list of what has to be done includes the following. Number one, develop a risk management plan. A risk management plan includes a review of the project scope, stakeholders, budget, schedule, any other internal or external factors that might affect the project. The plan should define the project roles and responsibilities, the risk management methods and procedures, and also categories of risk and contingency plans, which we'll talk more about. Next, you'd have to identify the risk. Now, risk identification is the process of listing each risk, assessing the likelihood that it will occur or could affect the project. The details probably depend on the specific project, but most lists would include a means of identification of the risk, a brief description of that risk, what might cause it to occur, who'd be responsible for responding, and, very importantly, the potential impact on the risk. Analyzing risks is a two-step process. You'll do both a qualitative risk analysis and a quantitative risk analysis. The qualitative risk analysis evaluates each risk by estimating the probability that it will occur and the degree of impact. Project managers can use a formula to weight the risk and impact values, or they can display the results in a two-axis grid using a tool like Microsoft Excel. In many cases, these values that you will assign will be based on the project manager's experience. But this is still a risk analysis. Quantitative is a tool that can help the manager focus on the most critical areas where risk and probability and potential impact are high. Now, the purpose of quantitative risk analysis is to understand the actual impact in terms of dollars, time, scope, or quality. Quantitative risk analysis can involve a modeling process called what-if analysis, which allows a project manager to vary one or more elements in the model and then see what the impact or outcome would be. In managing any project, it's essential that the project manager keep the business issues in mind and in focus. The major objective of any system that you're building is to provide a solution to some business problem or opportunity. If the system doesn't do what it's designed to do, that's going to cause more problem, reduce employee morale, and even productivity will drop. One other big issue in managing projects that you constantly have to be on the alert for is project creep. This occurs in a number of ways. Somebody says, oh, well, could it also do this? Oh, could it also do that? And the team wants to say, yeah, we can do that, we can do that. If you're going to add tasks to a project, there needs to be a very definite, systematic approval process. It should be documented, written, and there should be a group that approves all such changes. Project creep is one of the major causes of failure for projects. Another major issue is budget issues. Cost overruns typically result from one of a number of causes. Unrealistic estimates. We said earlier that the better your plan is when you first put it together, the better your project will run. Estimates can be based, again, on prior knowledge, on previous projects, similar projects, any number of things, but your estimates, both time and monetary, have to be realistic. And remember, anytime you add time to a project, you're also adding money. Anytime you try to shorten a project by adding resources, you're also going to add money. So that's where that project creep concept becomes critical also. You can also fail to develop an accurate forecast that considers all the costs over the life of the project. We've talked about total cost of ownership, and we'll talk more about that concept. Poor monitoring of the progress, slow response to early warning signs. I can't emphasize this enough. If you even suspect there's a problem, assume there is, and take immediate action to take care of it. Schedule delays due to factors that were not foreseen. This is where your risk management plan in part comes into play. The better you identify the risks, the things that can cause problems, the better off you'll be for the duration of the project. And finally, human resource issues. You're going to have people on your team who are going to turn over, get different jobs. Somebody could die during a long project. Somebody gets married. People want to go on vacation. People get sick. They might not be adequately trained, and maybe it's just a motivational problem. These are all things the project manager must take into consideration. Here are just a couple more thoughts on this slide concerning schedule issues and the problems that can result, again, if you didn't plan adequately and correctly to begin with. If a project is in trouble because of a lack of resources or organizational support, management might be willing to give the project more time, more commitment, a higher priority. Adding staff, however, will reduce the project's completion time only if the additional people can be integrated effectively into the development team. If the team members lack experience with certain aspects of the required technology, then temporary help might be obtained from IT consultants or part-time staff. Adding staff can also mean training and orienting new people, and in this case, that takes time away from the primary goal and can also actually delay the project. In some situations, adding more people to a project will actually increase the time necessary to complete the project. And there's a principle called Brooks' Law that identifies this. It was developed by Frederick Brooks, Jr., an IBM engineer, who observed that by adding manpower to a late software project, it only makes it later. He came to this conclusion when he saw that new workers on a project first had to be educated and instructed by the existing employees, whose own productivity then was decreased. In this chapter, we've talked about the project manager's responsibilities, scheduling, monitoring, reporting, all the things that a project manager will be required to do. We've gone over how a project manager identifies tasks, identifies task patterns, and the use he makes of that information in putting together the project plan. Now, the textbook says that sound project management involves the same skills as any other management, and that's only partially correct. Project management requires a unique skill set, additional training. It is a very specific type of management, and the fact that you may be a good business manager does not always translate to the fact that you would be a good project manager. Now we're moving to what's called the Systems Analyst Toolkit. In this first part, Part A, you're going to learn about written and oral communication skills that you're going to have as a systems analyst. There's nothing new, startling, or different in successful communications, but this chapter does an excellent job of providing a reminder and an overview. And communications is one of the essential tools for a systems analyst. It goes without saying that you have to be an absolute expert in your subject area. You have to know your subject inside and out. No matter how well you plan your communications, your credibility and effectiveness are going to depend on whether others believe you and support your views. Now, nobody knows everything. You're not expected to be the expert programmer, analyst, perfect at everything. But it is important to adopt a specific preparation strategy. For example, before a presentation, consider what others expect you to know and try to anticipate what questions they might ask you. However, no matter how well you prepare, you're not going to have an answer for every question. Remember this, it's much better to say, I don't know, but I will find out and get back to you, rather than to guess. I have seen instances where upper management will ask a question that they actually already know the answer to. They're testing to see if you're going to try to bluff or whether you know what you're talking about. So be very, very careful here. Here are a few style and readability suggestions that are going to help you. Know your audience. If you're writing for non-technical readers, then use terms they're going to understand. Try to stay away from acronyms. Always use active voice. For example, the active voice sentence, Tom designed the system, is much better than saying the system was designed by Tom. So keep your writing in active voice. It's critical. Keep your writing clear, concise, well organized. Each paragraph should present a single topic or idea. Review your material. Make sure that you follow these guidelines. Use an appropriate style. For example, use a conversational tone if an informal document is being submitted, and a business tone if it's a more formal document. Also, use lists. A topic that has many subtopics. A list, in this case, can organize the material and make it much easier to understand and much easier to grasp visually for the people that you're trying to get the information across to. Always use short, easy to understand words. Your objective isn't to impress your audience with the size of your vocabulary. And also, avoid repeating the same word too often. And this is hard to do. Use a thesaurus if you have to locate synonyms for frequently repeated words. Many word processing programs have a thesaurus built into it, but you actually have to use the tool. Always check your spelling. There are spell checkers built in. How embarrassing if you have words misspelled. Check your grammar. Goes without saying. And also, always review the work very carefully. Have somebody else take a look at it for you and make sure you haven't made any obvious error. With the advent of the web, the word netiquette entered into our vocabulary. Basically, it's a term that combines the words internet and etiquette. With the explosive growth of like social networking, netiquette is more important than ever. On the web, you can find many sources of information about this topic, but a few things to keep in mind. What you say on Facebook or Twitter, what your tweets are, that's one thing. But what you say in your written communications is something entirely different. Always be professional. Check your spelling. Don't forward jokes or chain letters without the permission of the person who you're sending them to. It's also important that you know and follow the company policy regarding your communications at work. Keep in mind, recent legislation makes email a permanent part of the company's history. Throughout the software development lifecycle, you're going to be called upon to create a number of reports, including like the preliminary investigation report, the system requirements document at the end of the systems analysis phase, the system design specification at the end of the design phase, and other reports such as status reports, activity reports, proposals, departmental business plans. You'll create reports as electronic documents so that you can attach them to your emails. And although most reports are delivered electronically, in some cases you will have to be able to prepare and distribute printed copies. In your reports, one of the things you're going to learn is what information goes to who. You'll have an actual communications plan in any kind of a project to identify who needs what information and in what format. An oral presentation is required at the end of the preliminary investigation, and it's again at the conclusion of the systems analysis phase. You might need to give more than one presentation in some situations to present technical material to members of the IT department or to present an overview for top managers. When you're preparing an oral presentation, you're going to perform 6 important tasks. Number 1, you're going to define the audience. 2, define the objectives for your presentation, which I've listed some of right below here. Organize the presentation, define any technical terms you will use, and then prepare your presentation aids and practice your delivery. Always, when defining your audience, take into consideration the expectations of the audience and their level of expertise and technical understanding. Now, when you communicate, you should always focus on your objectives. In the management presentation for the systems analysis phase, your goals I have listed for you here on this slide. You can read the remaining bullets about defining your objectives, but I'd like to move on now to actually organizing your presentation. First, when you're actually given the presentation, you should introduce yourself and describe your objectives. During the presentation, make sure that you discuss your topics in a logical order, and you should be as specific as possible when you're presenting your facts. Your listeners want to hear your views about what's wrong, how it can be fixed, how much it will cost, when the objectives can be accomplished. And in your summary, briefly review the main points and then ask for questions. It is also very important that you not read your oral presentation. By definition, it is an oral presentation. And remember to keep eye contact with your audience. Look at them, not at your notes. To the extent that it's possible, you need to avoid technical jargon, acronyms, technical terms. Where you can't avoid the use of these terms, then it is very important, especially when you're briefing or giving an oral presentation to management, that you define these terms. Don't assume they understand, and don't make them ask. Define them. Much of what people learn is acquired visually, so you should use helpful, appropriate visual aids to help the audience follow the logic of your presentation and also to hold their attention. You know yourself how difficult it is to sit in a classroom and listen to a lecture without having anything to look at. Visual aids can help you display a graphical summary of performance trends, a series of cost-benefit examples, a bulleted list of important points. You can use whiteboards, flip charts, overhead transparency, slides, films, videotapes, whatever. And I would say use a variety of these to enhance your presentation. A picture often really is worth 1,000 words. Finally, you have to practice. If I could, I should have written this 3 times. Practice, practice, practice. If you don't rehearse, you'll make mistakes. And as you well know, you have exactly one chance to make a first impression. If that first impression is poor, then that's the impression they'll carry for the remainder of this project. Rehearse it several times. Don't be tempted to write it down as a script, because you'll get into this bad habit of reading rather than delivering your oral presentation. And also, don't forget, it's important to establish a rapport with your audience. When you give your presentation, it's important that you show confidence about your subject and your recommendations. You should avoid any conflicts with people attending the presentation. Even if you encounter criticism or hostility, just stay calm, stay focused on the issues, and don't focus on the person who's making the comments. It's up to you to control the presentation. Maintain the pace of the presentation and stay focused on the agenda, especially when answering questions. Let your audience know right at the beginning whether you prefer to take questions as you go along, or if you want to have a question and answer session at the end. Sometimes questions can be extremely difficult. So listen carefully, respond with a straightforward answer, and as I said earlier, try to anticipate the questions your audience will ask and be prepared with those responses ahead of time. Effective communications is a key at every step of the software development lifecycle. You have to know why you're communicating, what you want to accomplish, who your targets are, what's expected from you when you go into detail. You also have to know your subject and how to use good written and oral communications techniques. In addition to practicing your delivery, a key element in developing slide presentations would be to follow the 6x6 or 7x7 rules. We didn't mention it earlier, but it is covered in the text. What it means is this: you display one topic per slide and try to follow the 7x7 rule. No more than 7 items per slide, no more than 7 words per item. Some presenters actually believe that a 6x6 rule is more effective. In this chapter, we're going to talk about case tools, which you can see defined right here. You may not be familiar with these, but at this point, trust me just for a little while, and you'll see that these are worth their weight in gold, and they can save you an enormous amount of time. Another thing that we will learn about in this chapter is integrated software development environments. We'll talk about several. Traditional code was written in what are called procedural programming languages. You may remember COBOL. It required a programmer to create a command for each processing step. Well, in contrast to that, modern languages like Visual Basic and Java are called non-procedural or event-driven program languages, because instead of writing a series of instructions, a programmer simply defines the actions that the program has to perform and when certain events occur. Because non-procedural languages are object-oriented programming languages, they make it easier to implement an object-oriented system design. And while object-oriented system design is covered in Chapter 6 of the text, we will not cover it during this course. And another trend involves very powerful programming languages called fourth-generation languages, or 4GLs. And they're part of the fourth-generation environment. We'll talk about that in Chapter 7, Development Strategies, in this text. But basically, in a fourth-generation environment, case tools are a big part. Systems developers can develop accurate prototypes, cut development time, and reduce expense. A repository is a database that serves as a central storage location for all information about the system being developed. Once a data element has been defined in the repository, it can be accessed and used by processes and other information systems. When you define a data element in the repository, you can assign a data type, a format, and a range of acceptable values and one or more aliases. And an alias is just an alternative name for a data element. By doing this, the repository can be searched and all instances of the data element can be listed. Throughout the software development lifecycle, you'll use a number of what are called modeling tools to create diagrams to represent the system graphically. The textbook describes many of these, including unified modeling language diagrams, functional decomposition diagrams, data flow diagrams, entity relationship diagrams, structure charts, to name but a few. One of the most important benefits in the case environment is that it provides a framework that allows a developer to create a series of graphical models based on the data that's been entered into a central repository. Now, documentation tools are another part of this. The main source of system documentation is the repository. In most case software, the repository automatically identifies new entries and adds them into the database. In addition to the repository itself, many case tool products provide tools that automatically check for inconsistent or incomplete information in forms, reports, or diagrams. In addition to this, there are two critical engineering tools that are very, very useful. Engineering tools include forward engineering and reverse engineering. Forward engineering means translating the business processes and functions into applications. That's a logical progression. Reverse engineering is a little different. This allows you to examine an existing application, break it down into a series of diagrams, structure charts, and source code. And then using the reverse engineering case tool, an analyst can transform existing application source code into a working model of the system. Then we also have what are called construction tools. The application generator, which is also called a code generator. This allows you to develop your computer programs rapidly by translating a logical model directly into code. You also have what are called screen generators or form painters. And this is just an interactive tool that helps you design a custom interface, create screen forms, and handle data entry and format procedures. The next tool here is what's called a report generator, also known as a report writer. It's a tool for designing formatted reports very rapidly. When you're using a report generator, you can modify a report easily at any stage of the design process. When you're satisfied with the report layout, the report writer creates a report definition and program code that actually produces the report. You can also input sample field values to create what's called a mock-up report that users can then review and approve or request changes. An integrated development environment, or an IDE, uses a built-in case tool that a software vendor includes to make it easier to plan, construct, and maintain a specific software product. For example, Microsoft, Oracle, IBM all offer IDEs that support their family of products. Oracle Designer is a modeling and application development tool packaged along with Oracle's application software. Visual Studio 2010 is an integrated development environment that supports Microsoft's family of .NET applications. And IBM describes its Rational Workbench as an integrated solution for systems lifecycle management. As with most things, IDEs have their pros and their cons. In a specific software environment, an integrated development tool is very effective because it's built into the vendor's software package. The only possible disadvantage is that each IDE is different, requires a learning curve, and the skills that may or may not be readily transferable. By contrast, non-specific case tools such as Visible Analyst or Rational System Architect can be used in any development environment. And given the dynamic changes that are occurring in IT, a systems analyst would be, I think, best served to seek to learn as many development and case tools as possible. While there are literally dozens of vendors that you can choose case tools from that manufacture case tools, we want to look at just a couple of the leading ones. The three leaders in the industry are Visible Systems Corporation, Telelogic Software, and Rational Software. In addition to the points listed on this slide, it's important to know that Visible Analyst case tools can generate all kinds of models and diagrams, some of which we're going to study in future chapters. These include an entity relationship diagram, a data flow diagram, and structure charts. IBM offers many development and modeling products as well, including a powerful tool called Rational System Architect. IBM claims that the product stresses modeling and collaboration and that it is a suite of tools that can align processes, information, and technologies. If you're interested in learning more about this, you can download a trial version of the software from IBM's website. The world of case tool vendors is constantly offering more features and greater flexibility. It's a very dynamic environment. As the software becomes more powerful and complex, the lines, though, between traditional case tools and other modeling tools will blur. An example would be Microsoft Visio, which can model networks, business processes, and many other types of special diagram. Visio also offers a variety of online tutorials and training sessions. In addition to which, with the professional version of Microsoft Office, Visio is included. This is a tool that is worth investigating. Method-specific case tools are mentioned here, but they're covered in much more depth in Chapter 11. As is explained in Chapter 11, each systems development approach has a set of tools that has worked especially well for that method. For example, structured development relies heavily on data flow diagrams and structure charts. Now, structured analysis is a very traditional approach that's time-tested and easy to understand. Structured modeling tools are described in great detail in Chapter 5, by the way, data and process modeling. The most recent trend is the popularity of what are called agile methods. Chapter 11 also includes a detailed description of an agile project, including the iterative cycles and the intense contact between developers and users. It's described as intense contact because in an agile environment, users are engaged and active at every step of the software development lifecycle. According to Scott Ambler, who's a well-known IT consultant, agile developers use a wide range of modeling tools, including case tools. However, many agile teams find that a simple whiteboard sketching is what works best for them. In this section, we've learned that case tools are software programs that system developers use to help them design and construct information systems. The advantage to these is that they can save you a great deal of time, and of course, time is money. You learned about a repository, which is a database that serves as a central storage location and everything that can do for you. And we also talked about an integrated set of case tools that can be used to model, document, engineer, and construct an information system. If there's any of these concepts that you have difficulty understanding, take a few minutes, go back over them in the text. Just as a quick review, CASE stands for Computer Aided Systems Engineering, and we've talked quite a bit about what CASE tools are and what they do. We talked about, and it's important to remember, what non-procedural languages, also called fourth generation languages, are all about. We talked about a repository in the database. We talked about an integrated set of case tools that can be used to model, document, engineer, and construct an information system. The main source of documentation, as we indicated, is the repository, which identifies new elements and adds them to the database. Now, forward engineering means translating business processes and functions into applications. Reverse engineering lets you examine an existing application, break it down into a series of diagrams, structure charts, and in some cases, source code. Two trends seem clear for the future. One, that case tool vendors will continue to include powerful new features, and 2, the popularity of object-oriented tools will continue to grow. I personally have not had a great deal of experience with object-oriented case tools, but this is an area that bears examination. We will not, however, cover object-oriented database design in this course.